Welcome to today's tutorial in basics on changing shapes using matrices. I have decided to do this video out of my interest and excitement about the idea of changing shapes using matrices. This can also be called as geometric transformations using matrices. At the end of this video, we shall see the application of this concept in the form of a Java program. And the major prerequisite that is required to understand this concept is matrix multiplication, which I guess is very trivial. However, we shall see that in a quick wrap-up. This is how we are going to multiply the 1 by 2 and 2 by 2 matrix, and this is all what we require. Now we are ready to do this visual part of mathematics, and we can formulate or we can postulate the general procedure in the form of 6 steps. So let us see what are those. The first step will be making a shape of your own interest and pick some points on especially on the perimeter of the object or perimeter of the shape, and write down the coordinates of those points. At least you take 10 points. This is the crucial step in which we make a 2 by 2 matrix using +1, -1 or zeros. We call this matrix to be transformation matrix. With this matrix, we multiply all the points that we have taken out of the shape, and after multiplication, we get some new coordinates for the points. We connect all these points plotted in a graph, and we try to observe the pattern that we have got. To let me illustrate the above procedure, I am taking a shape which looks like a dog. In this, I have given names for every point that I have sampled on the perimeter of the shape and written down its coordinates with reference to the origin. And these points are next going to be multiplied with our selected transformation matrix. In this case, I am taking the matrix to be 1, 0, 1, -1. If I multiply each and every point with this matrix, I'll get a new coordinate for the previous or the old point. So these are the points I have got, and what next I have to do is I have to plot these points and connect them in the order that I have taken. If I do that, this is the shape that is resulting in. So this is our transformed shape. If we closely observe, this is doing nothing but it is transforming the square or the rectangle into a parallelogram tilted by an angle 45 degrees. This phenomena can be related to the shearing stress concept in mechanics. So we can name this transform as shearing transform. Similarly, based on the type of transformation they do to the given object, we name them differently. In that manner, we can define squashing transform, which transforms the given shape entirely to a single line. And you can verify this. And the scaling transform, which magnifies or diminishes based on the scaling factor we define in the transformation matrix. So in this way, we can also define rotating transform, which rotates the given shape by an angle of 90 degrees counterclockwise direction. This matrix 0, 1, -1, 0 can rotate the given shape in 90 degrees clockwise direction. Similarly, we can guess the matrix which can rotate in clockwise direction also. At this point, I want to ask a question to you. You can pause the video and try the answer for this. Which matrix will transform the given shape to 180 degrees counterclockwise direction? You can think of this. I hope everybody got the solution. Here it is just multiplying the 90 degrees rotating matrix twice. So if we do so, the entire image rotates by 180 degrees. So the matrix which rotates the given object by 180 degrees is -1, 0, -1. Right? Let us make some important observations from the points discussed till now. To preserve the shape of the object, we need to take care that the diagonal elements should be 0 for the transformation matrix we choose. It should be in the either form. Our second observation will be from the rotating matrices. If we see closely, the matrices which rotate at 90 degrees clockwise or counterclockwise or 180 degrees counterclockwise, their determinants are 1, and the elements present in them are zeros or -1 and 1s. So let us try whether we can substitute the same with cos and sine. If we do that in a particular fashion, those actually be satisfying the transforms in all possible ways. So now we try to generalize the transformation matrix which can rotate the given shape to any given angle. This will be very helpful because we can rotate the given shape by any angle. So now our generalized matrix is cos phi, sin phi and minus sin phi and cos phi. Its determinant is also 1. And it can rotate the given shape by a given angle. Now let us see the application of this concept in a Java program, and usually we don't try to do this on a paper and plot all the points to the transform points, but what we do is we will use this in programming. In this, if you see this affine transform function, it actually does all the work that we have discussed till now. Here it transforms the points in the form of linear mapping in 2D coordinate system, and it makes sure that it preserves the straightness and parallelness of the shape. And if you see here, the transformation matrix is actually a 3x3 matrix. The third dimension is actually taking care of the shifting of origin. We are discussing everything with respect to origin 0, 0. Now we shall see the program, how it is going to execute for various angles I give as an input. This is for 0 degrees and I change it for 45 degrees, and here it is how it looks like. It is 45 degrees till that was given to the actual picture. Now it is 90 degrees. The entire picture rotated by 90 degrees. And finally this is the 180 degrees. Here you can see that every point is getting transformed to 180 degrees, and this is what we have discussed till now. Now what I try to do is, I try to bring out a loop in the program and try to plot for the image for all the angles, that is ranging from 0 to 360. That will give us something like this. This becomes an animation because it is running through all the angles as the input.